when it's an x squared. So really what you have to remember is this format for your x squared, and the other one when it's a y squared. And we are going to put the pieces in and see what we're missing, and then work from there. It's good to sketch because it helps you figure out where you are. So on the first one, and we said that this one has to open up because it could have been anywhere. The vertex and the point, and this one was going to open up. So this one gives us an x squared. So right away, start with this guy. Because your vertex is 0, 0, you kind of drop both of those. Yeah, you're finished checking. So Mrs. Norman. Yes. Yeah. Okay, you got it. Okay, all right, bye-bye. You, at the end of the period, the secretary in the academy guidance. You know where Miss Krause is? You know the academy guidance when you walk towards the main hallway, you come around like this, they're right over there. Midge, I don't know her last name, she's the secretary. See me at the end of class tomorrow. Help you get there. Okay, so now, you get down to, it's pretty large. Let me give you the cup. Would that be better for you to see closer? Right on if you need to. Okay, so we got to this one because the x and the y intercepts are 0, 0. So that started us here. Now notice you need to know p to complete this. P is the distance from your vertex to your focus point or your directrix, either way. Now remember, if it's opening up, it's positive. Now we can't find p in this because we don't have a focus or a directrix, but we do have a point on the line, and this is an xy point. So if you plug in for x and you plug in for y, those points, you should be able to find p. Once you find p, you have to bring it back into your equation, so then you can resolve that part and get the equation of your parabola. Okay? Sometimes you have a focus and a directrix, you can find p, it's easy. Sometimes you have a point on your parabola, you got to use the xy concept. We did like 3 or 4 examples on Friday, and we found p on a couple of them using a focus or a directrix, and then we use the x and y point. Questions? No? And you guys that were absent, are you kind of seeing this? No? So let's walk through this one. You guys that were absent, let's walk through this. We have a vertex. This is what you're given. So write this on your paper with me. Vertex, 0, 0. Focus, 0, -3/2. So where does this have to open? Down. Your focus has to be inside your parabola. So right away I'm opening down. I'm using the x squared version. I have to know these because it's an opening up or down, so I'm an x squared. What's the value of h and k at the origin, at the where our vertex is? 0, 0. So I'm going to take this out with the 0. Is that okay with you guys? X squared equals 4py. Now, either I can find p or I have a point x and y. In this case, I can find P. P is the distance. Distance, do it first, measure it, absolute value, from here to here. So P would be what? Just the number, not the sign. So 3 over 2, and because I'm opening down, P is negative. You don't have to remember your focus is your vertex minus your everything, whatever, B minus P, P minus B, X minus B. You don't have to memorize any of that because it's very confusing. What you have to do is look at your graph. Find the absolute value, find the distance. If it opens down, it's negative. Anytime you do the H plus PK and all those other things, it's confusing if you don't memorize it exactly. So don't use your graph. Now, take this value and plug this in here. X squared is equal to 4 times negative 3 halves y. Negative 12 over 2 is negative 6. Here's your equation of your parabola. Okay, that's all we did on Friday, was we used our sketch to help us find what pieces we would know for that graph, and we plugged it in. Okay? I'll walk through the next one because that's a y squared. All right, let's walk through this next guy, 53. We know we have a vertex of 0, 0, and our focus of negative 2, 0. So right away, which way does my parabola have to open? To the left. So that tells us two things. It tells us that P is negative, and it also tells us that we have the y squared version here. Y minus k squared equals 4p x minus h. Now, we plug in what we know. They gave us the vertex, 0, 0. So plug in a 0 here, a 0 here. So y squared equals 4px, that's an x. So we look to see if we can find P. Can you find me the distance? And sometimes it helps to just write them on your graph. What's the distance in absolute value from the vertex to the focus? How many did we walk over? 2. So P is 2. And we said, because it's opening to the left, P is negative. Easiest way to do that, plug this into here. Y squared equals 4 times negative 2x. Okay? Makes sense? You have to know those two equations, the x minus h squared and the y minus k squared, which I think you should know. You probably do know by now. And either you're going to locate a P and figure it out if it's positive or negative, or you're going to find a point on the parabola. Good? You guys that were in here, is it making sense? Aaron, Donovan, Tatiana, yes? Okay. All right. It really wasn't that much work involved. Okay, here you're given a vertex. The vertex at 0, 0 is quite nice. You're given a vertex, and you're given a directrix. Now remember, your directrix is the same distance as your focus is away from your vertex. And we don't care if that part's negative or positive. We're not going to worry about that. We're just going to worry about where is your parabola opening. So now, you start here at your 0, 0. Your directrix goes here. Your parabola cannot open up. It cannot cut through it. It cannot open to the side. It cannot cut through a directrix. The only choice it has is to open down. So therefore, is P positive or negative? P is negative. What's the distance from here to 1? 1. So P has a distance of 1, and we said P has to be negative. So find this. There's your 0, 0. We plugged in your 0, 0. We plugged in your P of negative 1, and we came out with your equation. Remember, these are conics. They're not functions. They're conics. Okay. All right, 57. Similar. We have a directrix and a vertex. Vertex at 0, 0. And again, parabola has no choice. It has to open up away from the directrix. So P is going to be negative. Your distance between your vertex and your directrix is 2 units. Since it's going to the left, P is negative 2. Plug it in, and you get your equation. 59. I had to give you a little bit more information on 59. I told you your vertex was at 0, 0, right? On 59. It's probably penciled in on those sheets that you picked up. It's a horizontal axis of symmetry. And the vertex was where that's origin. And it passes through a point. So when you know it's going to open this way, horizontal axis of symmetry, it's got to open this way. It can't open up, because then it would have a vertical axis of symmetry. So we start with your x squared guy, your y squared guy. Plug in your 0, 0. Now, we try to see if we have a P. In this case, there's no way we can get P. There's no focus, there's no directrix. But there is a point on your line. This point is an XY point. Label it XY. It's easier to see where to put it. So put your Y in here. Put your X in here. Now solve. Solve for your P. And once you solve for P, plug it back in so that you can find your equation. You need to give me the equation that you would begin with. So you have 36, if you want me to work it out. We just reduce this to 9 over 4. And we know this is positive because it opens to the right. So P stays positive. And when we plug this back in, the denominator goes away, and you get y squared equals 9x. Okay? I think there's just a little bit more work when you have to use an XY point, because you have to find P and then bring it back. Question, Aaron? Well, because this horizontal axis says this is your axis of symmetry. So my parabola has to come around my axis of symmetry. And that's a good question, because if it was that point, it could go up, but that would have a vertical axis of symmetry. It's just different ways that they'll ask you this. I was missing something, which was where your vertex was, so I added the vertex to that. You have a vertex now that is not 0, 0, and you have 2 points on your parabola. So here's my 2 points. There's my vertex. As soon as I draw this, 3, 1, 2, 0, 4, 0, and I have no choice. This has to open down. I've got an x squared that opens down. Therefore, my P is negative. Start with this guy. This is your H, your K. So you're going to start with this. You're going to plug this in. 3, 1. That's where your vertex goes. We then pick either of those points, either of those XY points. They're both nice points. One has a 0 and there's no negatives. So I would stay away from negatives, because then you're dealing with negatives and subtracting. But you could either put the 2, 0 or the 4, 0 in here. You'd be okay with that. Now, solve this for P. P, again, you're going to find is negative. Then plug P back into your formula over here. Plug this back in and resolve your equation. You should see the negative out there. You should be able to pull the vertex out of there. Good. Those of you guys that were in here, is this making sense? It's like the same kind of system over and over again. Depends on the parts you're getting. This is the part you have to use. And you have to remember to plug P back in. This one's similar, only it's pointing the other way. It's a y squared. And P is positive on this, so you're going to, once you find this, you're going to see P is a positive. Plug the P back into this piece over here, and you get this answer. Okay. Again, you could pick either point. Personally, I'd stay away from, oh, I did pick the negative, didn't I? I'd stay away from the negative, but, oh no, I didn't pick the negative. No, I picked the positives. I'd stay away from the negative only because you're dealing with a negative, and I know how you love to subtract negatives. Be careful on your vertex because that goes in the opposite, remember? There's your x minus a negative 4. Becomes x plus 4. Questions? No? Okay. All right, 83. There's your focus and your vertex given to you. Start your equation, put your vertex in there. And again, I would not bother with the formula. I would come here and say my distance here is 3/2. Okay? And it's got to be a positive, right? It's got to be a positive. I'm opening to the right. Plug this in for your P. Where's my P? Wait a second. Okay, not the right. Let me take this back. What's your vertex on? Your vertex was negative 2, 0. And your focus is negative 3/2, 0. So what is your distance of P in here? From 2 to 1.5, what is your distance of P? 1/2, right? And you can tell that it's going to the right, so P is positive. So once you plug your vertex in, just go here, find this, and plug in your P. Skip all that stuff right here, and come down to this. That's if you use your formula. I think it's much harder to use your formula. You have to figure out which one to use. You have to figure out which way it's going. I would just find the distance of P. Is it positive, is it negative, and plug it in. If you like the formulas, that's fine. I know some of you use formulas on your quiz. And that's fine. Okay with this? Well, I gave you guys a lot. I did. But look how much fun they are. Your focus, you should be able to find P, the distance between, look an easy way to do this too. Here's your 2's are the same. So what's 5 minus 3? 2. There's your P. 2. If it opens to the left, P has to be negative, right? So there's your negative P. So start with this. Skip all this. Plug in your negative 2. And there's your equation. If you like the formulas, please be my guest, use them. I tend to like the graphs. Okay? And because you enjoyed these so much. Here's another one. Again, I use the formula. You can just go and find the difference between 4 and 2. So your difference is 2. It's positive, so your P is positive 2. Plug your P in, and you should be able to resolve that. And I think this is your last one. Again, your distance here is from your vertex. We didn't know a vertex on this one. We only knew your focus and your directrix. Now, your vertex is halfway between. So if the distance from here to here is 4, half of that way is your vertex. So 2, either way, come to your vertex. So your vertex is going to be 0, 2. There's your vertex. And you can find P. P is 2, positive because it opens right. And plug them in. Good? Since this is making Jada tired, we're going to have to move on here. Ready? All right. So, what I thought... All right. So, let me set this one up with you guys, and then you could work on the rest of this text. Now remember, you want your square to be on your left-hand side. If you don't know this format, write this format on top. and then write the one for the x minus h squared. Write this at the top of your paper. Okay? So when I see this square, all I want to do is reflect this. I want this on this end. I want it to line up to those equations. Now, you take this and line this up right underneath this. Oh, I did this backwards, but you know what I'm saying. I wanted you to swap this so that it lines up to this guy, your standard equation. From this, remember, your h is always with your x, regardless of what side it comes on. Your k is always with your y. It's alphabetical. X before y, h before k. That's your vertex. Pull out your vertex first. So what would be your vertex of this guy? 4, negative 3. Good. Go like this next. 4p is equal to 8. Therefore, p is equal to 2. So, I have a y squared, and my p is positive. Which way is this going to open? To the right. So I locate my vertex. Remember, these are just sketches. 4, negative 3. And I'm opening to the right. Okay. I should be able to, here's my axis of symmetry. If this helps put your axis of symmetry in here. You're going to go p units to the right of that, p units to the left of that. So p we found out was 2. So if this point, and if it helps you, put it here. Your x is changing. If you move 2 units over, what is this focus point? Good. If you move 2 units backwards, remember this is going to make a line. Do we need the x value or the y value? The x, because that's the guy that's changing. 2 units from 4 is what? 2. There's your directrix. There's your directrix. Okay, so we know our focus point, we know our directrix. The only other thing we're missing is the intercept. Now, I just said find the focus directrix. Find the intercept as well. Don't find the one that's not there because it's not going to be there. This I want to find is my x-intercept. If I want the x-intercept, I have to set y equal to 0. Now, since you're only given the one equation, start with that, and it doesn't matter if you use this one or that one. So let's put it the way we want it to. We want the y of 0. So 3 squared is 9. 8x minus 32. You just have to solve this. Add 32 and divide by 8. And there's your intercept. And it kind of makes sense because that would be a little bit more than 5, right? 5 and an 8. Here I am at the 4. There I am at the 6. So I probably cross somewhere in here at the 5, which makes sense to me, right? I wouldn't certainly want to cross at the 10 or the negatives. I would want to cross close to that. If you have a y, do the y. Put x for 0. So you're going to do this packet for review. We're going to review it tomorrow and take a little test on Wednesday.